I've received a lot of questions about how to cut a long metal using the pass-through. In this video, I'll use a 1mm stainless steel as an example. Before cutting, insert the material through the device's side slots. You can start from either side slot. In this video, the metal is slid from left to right. Before securing the material, ensure the distance is equal on both sides, right where the arrows are pointing. Otherwise, the material may have an angle shift. After alignment, tighten the knobs on both sides. Next, install a proper nozzle for cutting. Here, I installed an ordinary cutting nozzle and use xTool air compressor with 600 kilopascals gas pressure. Open xTool software, connect your device, and import your design file. Process the letters. For example, the letter O. If we cut O directly, only a circular shape remains on the material. To preserve the ellipse inside, we need to perform extra operations. First, add a rectangle. Then, unlock the aspect ratio. Set the width to 5 mm. The rectangle appearance is adjusted accordingly. Center the rectangle vertically within the letter O. Press Shift and click the letter O. Click Combine and Subtract. In this way, the ellipse inside O is preserved. Since the patterns are separated, we need to unite them as a whole. Note that the letters and the two holes should be hollow. Select the two holes. Press Shift and click the frame. Then click Combine and click Subtract at Overlap. The holes and the frame are now united. Before uniting the frame and the letters, ensure that the letter layer is above the frame layer. Click the layer icon. The letter layer is now under the frame layer. We need to move it up. Click the letters, press Shift and click the frame. Then click Combine and click Subtract at Overlap. Here, we get the final design for processing. As the pattern is too long for the canvas, we need to split it manually. First, rotate the pattern 90 degrees. Add a rectangle. Unlock the aspect ratio. Adjust the rectangle position. Try to split from the blank space to minimize subsequent calibration errors. However, in this video, if we split from this position, the pattern on the right side would be over 600 mm long, so we can only split from the middle of the letter C. Now, let me show you how to split the pattern. Select the whole pattern. Use Ctrl+C and Ctrl+V to copy and paste. Place the copied pattern below. Then click the rectangle, press Shift and click the pattern. Then click Combine and click Subtract at Overlap. Here, we get the left half. Next, we need to get the right half. Click the rectangle, copy and paste it. Align the rectangle edges. Delete the rectangle on the right. Click the rectangle. Press Shift and click the pattern. Click Combine greater than Subtract at Overlap. Now we've split the pattern into left and right halves. But you'll notice 4 unwanted lines in the patterns. Next, I'll show you how to remove them. First, align the patterns. Then, double-click the right pattern to trigger the editing mode. Click the scissors icon. Place the scissors cursor on the unwanted line. When the line color changes, click the line to remove it. Click Done. Do the same to the left pattern. Double-click it. Click the line when it changes color. Click Done. And that's it. The two patterns are ready. We can use different colors to distinguish the patterns. Select all and set parameters on the right panel. Select Cutting with Fixture as the processing mode. Select 1mm 304 stainless steel as the processing material. Click Apply. Select xTool air compressor as the shielding gas. Select 2mm cutting nozzle as the working nozzle. Adjust the patterns. Click the red pattern and disable output. Otherwise, an error will occur. Adjust the black pattern position. Remember to reserve 1.5 centimeters between the edges of the pattern and the material. Next, click Calibrate the capacitive sensor. Then click the material. After the calibration is done, click the framing icon. Press the button on the device. Click Process. Read the instructions on the right panel and ensure that the cutting tip knob is set at the value -1. Click Start. After processing, wear heat-resistant gloves for subsequent operations. Loosen the fixture knobs on both sides. Move the material parallel to the right. Next, make sure the distance to the machine frame is the same as before on both ends, as indicated by the arrows. Otherwise, the angle may shift. Remember to tighten the knobs. We can see the half letter C, along with 2 cut lines. Next, move the red spot of the welding head to the joint point. If the red spot size is large, ensure that its center aligns with the joint point center. In the software, lower the welding head along the Z-axis. Click the downward arrow. The red spot gets smaller. Proceed with fine-tuning. Back to the patterns. Remove the black pattern from the canvas and disable output. Then click the red pattern and enable output. Place the red pattern on the canvas. Next, align the patterns. Add an arrow pattern. We can use a different color for the arrow to distinguish patterns. Enlarge the green arrow. Align the arrow tip with the laser crosshairs. Make sure they overlap exactly. To ensure accuracy, record the X and Y axis coordinate values. X1 is 565.3. Y1 is 20.7. Next, just repeat the same steps. Move the welding head to the joint point of the second cut line and lower the welding head along the Z-axis. Next, copy and paste the green arrow. Align the arrow tip with the laser crosshairs. Then record the coordinates values. X2 is 566.5, Y2 is 320.6. Now let's see if the pattern matches the 2-point coordinates. Align the pattern corner to the arrow tip. Observe the other point alignment. If the alignment fails, the material angle was shifted in the previous step. In this case, calculate the slope using the 2 pairs of coordinate values. The slope calculator link is in the comments section. Enter the coordinate values in the slope calculator. The angle value is used for the red pattern adjustment. In this video, the angle value is 89.77. Subtracting 89.77 from 90 yields 0.23. In other words, the slope is 0.23 degrees. Back to the xTool software. Since the pattern is tilted counterclockwise, the slope value should be -0.23 instead of 0.23. Click the blank space. The angle is now refreshed. Align the pattern corner with the arrow tip. Now both corners matches exactly with the arrow tips. The pattern alignment is now done. Delete unnecessary patterns and letters. Remember to enable output for the red pattern. In this step, we don't need to calibrate the capacitive sensor again, but we should perform the framing to check the alignment. If the alignment is okay, click Framing Completed. Click Process. Click Start. Loosen the knobs on both sides. Push out the material from the side slots. Now the cutting is finished. Let's see how the joint point result. Even though the alignment was manually set, the precision is quite good as long as we follow the operation steps. You can't even tell it was manually adjusted. If you need to cut a long material, follow this video to operate.